a shot and I'm unstoppable. That's all I know, that I'm unstoppable.
Hello pilots, it's Drax here, and in this tutorial video I will show you how to build fast, lightweight and durable Tinywhoop. So stay tuned. So we can start with the flight controller for our racing Tinywhoop, which will be BETAFPV F4 Cross flight controller. Exactly, this is the AIO board without the VTX, and it have really strong ASTs. The top tier pilots of Tinywhoops are using this flight controller, so it's really nice. It has serial ILRS, you can flash ILRS firmware just separately like on the normal full-sized ILRS receiver, and also it's really lightweight. And when you receive this flight controller, this wire is touching the BMI 270 gyro, which can be not good because it can transfer the vibrations on the gyro itself. So I moved this antenna like this side and this route right here, so it's not touching the gyro. Also, I glued this antenna on the B6000 glue, so it will not move anywhere, and during the crashes it will be safe out here. So the next part will be the BETAFPV Meteor 65 Pro frame. So it have a little bit bigger duct, and we can use bigger propeller in order to gain a little bit more power. So in order to be even more lighter, I deleted these duct connections, so Tinywhoop will still fly really great. So it really doesn't make any changes on my actual pit tune. It's really nice to have some flex right here, so we will not damage the shafts as much. So the next part will be the camera for our Tinywhoop, which is BETAFPV CO3 camera. This is top tier FPV camera from BETAFPV. It have a little bit bigger sensor than CO2, so it performs in low light conditions a little bit better. Also it have really nice protection O-ring right here, and this is not a plastic, this is metal, so it's really nice and high quality. Our FC doesn't have VTX, so we will use OVX300. It weighs only 1 gram, is smallest and lightest as possible VTX that you can buy, so of course we will use it on this build also. For the VTX you can use this normal whip antenna, which will give you a little bit better feed on the goggles, or if you want to go extreme low weight, you can delete this UFL connector with this switch and solder just a normal copper wire, but the signal will be not as good. To connect this VTX, we will also use some 32 AWG silicone wire, so it's also good to have some. And of course, really important part on this Tinywhoop are the motors. So we will use SE0702 motors with of course higher kV rating, which will be 28,000 kV. So these motors have really a punch and are pretty lightweight, of course a lot lighter than 0802 motors. The props for this Tinywhoop will be these bi-blade 40mm props, and I will later cut them to 35mm, which Meteor 65 Pro requires. And the reason why I'm using bi-blades instead of tri-blades, the first thing, because 702 motors are not as big as 0802 motors, so with the tri-blades it will really struggle. Also on bi-blades we gain a lot more durability because there is a less chance that when you hit something, actually propeller will hit it in the condition when you have tri-blades. When you have two bi-blade setup, is a little bit more durable, and also the top speed is higher. And now for the canopy, with this CO3 camera you will receive this plastic canopy, and it's pretty okay and durable, but it's a lot more heavy than this. TPU 3D print that I made on my 3D printer. If you have 3D printer, you can just print these. They are open source models on Thingiverse. You can get them really easily and 3D print. But if you don't have any 3D printer, you can just use this mount instead. And also good to have custom made 90-degree pigtail wire, and later on the video I will show you why I will resolder this main power lead. And from the tools that you will need is of course the soldering iron with small tips, because these things are really tiny and it's really good to have small tip of the soldering iron. The next thing is the flax, and it will make your work a lot easier and less chance that you will make bridges and burn something when you have proper flax. Really important tool when dealing with these tiny parts are really good tweezers, and especially for Tinywhoops I use these extra tiny tweezers. They are making this job really a lot easier. You can get these like for $2 on AliExpress, the set of 3 of these, so it's really not expensive but can make your life a lot easier when dealing with these small Tinywhoops. Later also we will use this 0.885mm drill to drill these props a little bit, because they are really tight, and if you crash with these tight props on, even when it even is really hard to take them out. But also if you fly and crash into something, it's easier just to break the shaft inside of the motor, so the bell will be spinning freely from the shaft, and this is really easy way how you can destroy the motor. So when the propeller will be a little bit more loose, instead of destroying the motor during the crash, the propeller will spin on the motor, on the shaft of the motor, so you will not damage the motor, and this is really also really nice durability tip. The screwdriver for these tiny whoop motors screws, and also for the flight controller screws. And of course the solder, so it's a lot easier work when you have this ultra thin solder, but also it's possible with this normal regular one. Double-sided foam tape, so this is better quality TASA tape, so we'll stick the OVX300 to the flight controller, and also it will protect the OVX300 because it's soft, and during the crash the OVX300 will not hit the flight controller, so it's really nice and also will be durable. The first step, I will prepare and solder the OVX300 wires, and the connection order will be like right here, because this is really tiny, so I don't know if I can show you clearly, but the pad order on OVX300 is V, which is video, A, which is smart audio, G, which is ground, and 5 volts, which of course will connect 5 volts from your flight controller. I have nice small hack to solder these small wires and do it clean. First, strip a lot more of this wire than you need, then thin this wire with the soldering iron, and then, if will be thinned, cut this to the proper length. So later, when you will touch to the pad of the OVX, it will not break on the separate strings. It will be just like a one solid string, and it will be a lot easier to solder. And now when I have these wires thinned really nice with plenty of flax, I can cut these ends on the proper length. So now I have 100% guarantee that they will not get messy when I try to solder them on these tiny pads. Because we have couple of strings on this wire, and this is really important when you solder this wire to the tiny pads of OVX300 to be in one single piece, because if even one little bit of string get out of its way, you can get a short circuit. Add a little bit of flux on these pads because they are really tiny, and flux here will be really useful. Take a tweezers and I can start off from the 5-volt pad. So you can take this wire with the tweezers. Yep. Maybe I do this a little bit lower. So often I use for the smart audio white wire, for the video yellow wire, and of course for the ground black, and 5 volts will be red wire. Yeah, so we have something like this. So we have 5 volts ground, white is smart audio, and the yellow is video. So this is really important to not make bridges, because these pads are really close to each other, so use plenty of flux and little bit amount of a solder. Now I will remove the pigtail wire on this F4 flight controller, because, and I tell you why I need to do this. When we take this Meteor 65 Pro frame, of course this cross fits perfect to this frame because it have these cutouts for the ducts, so it's even possible that we can fit it right here. But this wire is a little bit too short. We can put it on the mount. Also, it's good to change a bigger tip for the soldering iron, because this solder is lead free, and also you need to crank up the temperature a little bit, like to 400 degrees, because it can be a little bit tricky to get it out. And also I will measure the right length of this 90-degree pigtail. So I'll just take this frame. The flight controller will be like this way, with small backup, of course. It will be something like this length. I turned off the soldering iron, and now I can exchange the bigger tip to resolder this main power lead. So I will get something bigger for this job. It should be this tip. It's like a 1 or 2 millimeters bigger. It will melt this lead-free solder a little bit better. So now, of course, we need also to crank up our soldering iron, like to 400. Yep. Now I will prep, and we will see how long we will need to heat it up to be able to remove this old pigtail. So I will grab it from the bottom to pull it out, and now apply heat from the soldering iron on the top. So for the positive, it should be really not hard, because this pad is really not big, but for ground we need to apply a little bit longer, because this pad is big, so it's always harder to solder the ground. So we need to hold it a little bit longer. And I also apply some normal lead solder to make it easier. Like 5 or 6 seconds. Yeah, it's a little bit harder to get it out, but it should. Oh, and now we have it. So we also have ground out. As I told earlier, we need to apply some more of this heat, so now I can go back again to like 370 degrees, and now prep these pads for a new pigtail. And also I added a little bit of solder to these pads to solder a new one. Thin the wire for the new pigtail. And we are still using this bigger tip, so also it will be easier to solder a new big pigtail. If the wires are too long, you can cut them a little bit. Also, you'll have less chance of short circuit, but when everything will be nice and clean. For the main power lead, also is great to add some flags. So yeah, and also when soldering the new pigtail, make sure that you have these pads free, because later we will solder the peripherals to these pads, so it's great to make a free space right here. So we take the flight controller and put these gummies on it. Just push it through and you have these gummies like right here. So you can do this for all of left 3 of these. Alright, so now we can prepare the OVX300 to stick it on the bottom of this flight controller. So we can take this VTX and use our nice foamy double-sided tape, the small sized piece. And I like to have like 1 or 2 millimeter more of the tape than is the size of this OVX300. So also the outline will be a little bit protected from the flight controller, and also flight controller from the OVX. Of course, make sure that the UFL connector will be at the bottom of the Tinywhoop, so the flight controller side will be right here, a little bit bigger than the VTX itself. Like you can see, I have a little bit of backup right here, and now I will just cut these two sides with the scissors, also to be a little bit bigger right here. Okay, so we have our VTX prepared to be installed. We can also see that this foam protects the wires, particularly the soldering joints also from the AIO board, so it's really nice to use foamy tape to this. Yeah, and as I told you earlier, I will stick it like on this orientation, also to make it as much on the middle as possible, but it cannot be straight on the middle because we have this inductor right here, so it needs to be a little bit on the front side of the flight controller. Okay, so that's alright. Now we have really short route to these pads, so this is good. So I can bend these wires, and then I will show you how to solder these wires to the flight controller. Cut these wires to proper length, and of course leave some backup. So in the future, if you want to change something, it will be still possible. I can strip these wires, and also I will take the camera wires. Alright, so I have VTX, I also can bring camera right here. I can thin the pads and also the wires. Alright, add a little bit of flux on these pads. And when I thin these pads, I show you for which one of these we will connect these peripherals, which is really important and a lot of people make mistakes. So I will show you the proper way how to connect them. First I will just thin these pads. Okay, nice. So we have also, I will thin the wires of this VTX. You can even see from here that I have a lot of flux right here, so it will make my soldering job a lot easier because these pads are really nice. Also, I will cut these wires, the ends of these wires to be really short now, so it will be also cleaner later on the build. Alright, so I will show you the connection diagram. So the T2 port is for the smart audio for the VTX. So this is labeled E port, so this is like in, so the video goes in, so we will solder the camera to this in port and the VTX video to the O port. So this is just like a out port. So this is pretty self-explanatory. This is out port, so for the VTX. In port is for the camera. Of course, ground is ground, and 5 volts right here is the 5 volts to power our VTX and the camera. So you can spot that the 5 volt pad is in a little bit tricky space. It's right here. So don't do mistake and solder it to the ground of the USB connector because the labeling is a little bit off, but this pad is right here. Okay, so first I soldered the VTX. You can see right here how it's soldered. So we have T2 port is the smart audio, which is white. The yellow wire is the video for the VTX, so it will be output on the AIO board. And of course ground and 5 volts, which is right here next to the LED pad. Now I will also take the camera and the wire and wire the camera. So we'll take this video wire, solder it to the flight controller. And now is tricky part because we have one pad of the ground and 5 volts, but we need to connect 2 wires to one pad. So now as the second power wire for the camera, we need to solder the ground for the same pad as the VTX. So now we have 2 wires on the ground and 2 wires on the 5 volts. So of course I can show you that you can see clearly the same pads are powering the camera and the VTX. Now we will solder the motors, and to solder motors I have this special holder. Of course you can do it by the hand, just take tweezers and put the wires, but I'm doing it like this way, that I'm installing the flight controller on this special holder and then just put the motor wires on these slots and just solder all of them at once. Just solder wires to the flight controller. The best way is just to make straight connections, so the like motor is this way, Only most important thing that the middle wire needs to be soldered to the middle pad of the AST, and then when you swap the side wires it will just spin the other direction, and then you will just tweak it on the AST firmware. So we have our motor soldered, VTX and the camera. So the main part of the Tinywhoop is ready, and we can put it on the frame. We can take our frame, and of course front of the frame will be right here and the back of the frame will be right here, and this is important because later we will push the power pigtail through this hole. You can pop on the place this antenna, so later it will be just easier to mount it. Alright, so we just push the motors through these holes, you can see. Alright, also don't forget about the VTX antenna, to put it down here, like in this space. Yeah, so you can put the VTX antenna through this hole. Now I will screw the motors. You can see the layout of the screws. I just use only 2 screws per motor, and they are on the inner side of the drone, like this orientation. Also make sure that these screws are tight, but of course not too tight to not strip the threadings on the motors. Alright, now we can mount the camera and the canopy. For the camera protection, I will also use this double-sided tape to stick this piece of a foam. We can use knife and cut the small hole in this foam to this camera, so it will fit a little bit better. So you can see when I put the camera, it sits nice and tight. I can now stick this foam right in this spot for the camera, and now I will take the TPU mount and push the camera through this hole. Alright, so we have the camera inside, and now we can take 4 provided screws with the flight controller, and I will show you which screws, because these are 2 sizes. These black ones are the bigger screws and these silver ones are the smaller. So I recommend to use these smaller screws because there is a less chance that you will break these standoffs. So it's great to use the smaller screws, and of course the smaller are lighter. And now, before screwing the last screw from the canopy, we need to finish installing the pigtail and the VTX antenna. So first we need to push through this pigtail through this hole. So I can show you how we need to bend this wire like this, and now it should make its way through this hole. This is pretty tight fit, but it's possible. When it's really hard, you can cut out a little bit of this plastic right here, so it'll be just easier to put this pigtail through. Yeah, like this, and we can pull it through. Nice. And now, when we installed brand new pigtail with this routing, now the stress from the LiPo and the crash of the moving LiPo the stress will take the frame, not the flight controller. And now when we have power pigtail, we can put through the VTX antenna. Alright, we have VTX antenna right here, and also the power wire. Now we can install the props, and of course the standard 40mm. You can see that they are too big for this duct, so we need to cut them down a little bit. So you can use normal pliers with the ruler to have proper length, or you can 3D print some kind of this device. It's really open source. You can get a model on Thingiverse, and I just adjusted it to cut for the 35mm of length. Alright. Prob is too tight. You can drill it a little bit, but mine, you can see mine are pretty loose. Also, when you have scenario that you drilled too much inside of this propeller and it's too loose, so you can see it's really loose, you can still save this propeller by using the dental floss. So I can show you right now, nice little hack, how to get these tight if they are too loose. So you can take a small piece of dental floss, put it through the propeller. So if it's really loose, you can even fold it on 2 pieces and put the 2 pieces inside. Make little bit of dental floss that will stick outside, so it'll be just easier, more thicker, and it's a lot more tight, but of course not too tight. And now you can see it holds pretty nice. And just cut the excess of this floss with the pliers. Bang! It's really nice, and now holds pretty well. So that's everything in this video. So yeah, our build is finished. Only 2 things that you need to do now is just flash the serial ELRS receiver with your binding phrase or your firmware, and also set the BETAFPV Cross flight controller. So everything is done. So let's check what this baby can do. Of course, my flying skills are not the best. I'm still learning how to raise Tinywhoops. And in this video also we'll see a couple crashes here, how durable it is, so we can just turtle and fly away. In extreme conditions, when you are going full speed and crash into the wall or multiple walls, you can get a bent shaft, but it really happens not as frequently as on the regular 65mm and tri-blade setup. So that's everything for this video. I hope that you learned something new today, so bye bye and stay creative.